Hello everyone. Welcome to this Microsoft build session on quickly deploy NVIDIA optimized generative AI applications on Azure AI Studio and Azure ML. Um, my name is Vineeth. I'm a senior solutions architect at NVIDIA. Me, along with my colleague Manuel, are going to introduce you and get you started to deploying enterprise models, enterprise AI applications using NVIDIA accelerated software solutions on your own enterprise infrastructure, on your own Azure infrastructure. The last 2 years, we have seen a significant adoption of generative AI since the explosion of ChatGPT in 2022. Until now, we have been trying and figuring out how we can use generative AI for enterprise applications. Fortunately, 2024 is going to be that year where generative AI are enterprise are showing a lot of interest in deploying generative AI in production, and NVIDIA has solutions that can help enterprises in doing that. Creating code that would like make your developers' life efficient and development cycle faster. So how are enterprises deploying generative AI today? There are mostly like two different approaches they take. One is using an existing API model API provider. So this is easy to use and it's the fastest path to get started with AI. But the thing is, the infrastructure access to the infrastructure is limited. You don't know what's going on with the model within the API. It's within the boundaries of the API provider, and you would the enterprise would have to share sensitive data outside of the enterprise, and therefore it can be a privacy concern. And overall, there's a limited control on the model's hallucinations and like what knowledge it has been trained on and fine tuning, etc. Then you have the open source solution, where it gives the enterprise the ability to take an open source model from Hugging Face or something, deploy it on data center, on cloud, or wherever they prefer. And they can also this way they can also manage the data within their own infrastructure, so there's a lot more control. But you would have to kind of like the enterprise would have to like maintain the infrastructure, and they would also have to figure out what is the right way to tune these models so that they run on the highest performance on the GPUs. Most of this requires some expertise and some AI research knowledge, which and also takes time to deploy models in this fashion. And a solution to this problem would contain three components, as we have rightly identified as shown here. One is it should have like optimized versions of state-of-the-art LLMs like Llama, Mistral, etc., which are seeing some traction in the enterprise world. It should have pre-built recipes on how to deploy this model in a performant manner without expecting the end user to know anything related to like GPU performance optimization, etc. It should have like an inference server where features like multi-device, multi-node parallelization are provided. It should allow for concurrent requests being pinged to that particular endpoint, and probably also offer like token streaming features and so on, so that it gives like a ChatGPT like experience in the enterprise world as well. And then the third feature being the optimization feature. It should have some intelligence into batching requests coming from different users dynamically, quantizing the models, including mixed precision, int4, int8, FP4, and whatnot. Basically trying to get the best out of the advantages that the GPU hardware provides. And also some intelligent stuff like kernel fusion, etc., to ensure that end-to-end latency to serve the request reduces. So the solution that NVIDIA offers is called as the NVIDIA NIM, the NVIDIA Inference Microservice. So as we see here, it's an accelerated runtime to deploy your generative AI applications on. It has optimized inference engines. It can support your custom models that you might fine tune and get from Hugging Face. It offers industry standard APIs, like it follows OpenAI API spec, so that you can convert your existing generative AI applications that are already probably interacting with OpenAI spec into an NVIDIA NIM deployed one. And we also offer all of this technology, including the NVIDIA's inferencing engine and the optimizations engine, etc., into one single container, along with some examples, Helm charts, etc., that will make it easier for you to deploy into a Kubernetes deployment, or even like ML services like Azure ML. So some of the key advantages include that with NVIDIA NIM, you get the best of both worlds, where you also get the ability to deploy your model in a performant manner like a model developer would, but at the same time within your own infrastructure, so that you don't have to send out your data to an external third-party API or something. Then you also have the it simplifies the development. It basically like captures a lot of the NVIDIA's internal intelligence on how to deploy these models into a single piece of software so that you don't have to go through all of that. We offer day zero support. So for any Hugging Face model or for any model that gets popped up in the outside world, you can deploy it within in using NVIDIA NIM in the day zero itself. You also get the promise of the best latency and the best throughput without having to know anything about how to achieve that. And and the best part is all of this is available in enterprise software format, where you have with the option of feature branches, validation, support, security checks, and so on. So you don't have to worry about deploying it using the open source way. You can do it in a robust enterprise software manner. So with Azure and Nvidia, that's all that you need to do your enterprise generative AI applications. So you can get your enterprise model either from the Azure model catalog or from Hugging Face, and then you can turbocharge it with the Nvidia software, in this case, Nvidia NIM, and you can take this deployment and use this Nvidia NIM deployment, and you can use this Nvidia NIM setup to deploy on an Azure VM instance or an Azure or an instance within Azure ML or even Azure Kubernetes service. NVIDIA NIM will simply create the optimal engines for your model of interest, independent of which Azure service you choose to deploy your model on. So that's the three-step process to get your that's how Azure and NVIDIA come together to deploy your enterprise AI model. In this demo, we look at how you can deploy a model from Azure catalog using NVIDIA NIM. Yeah, so here is an architecture diagram on how your developer and Azure ML developer within your company can deploy a model from Azure ML catalog in few steps. So here, the first Azure ML developer writes a deployment YAML file. This file is similar to the is as provided by the Azure ML deployment schema. In this file, they provide what model they want to deploy, the environment of NIM they want to use, and some variables that specify how many GPUs are being used, etc., so that NIM can create like a performant optimized model to deploy a model on the specified compute infrastructure. And you use the Azure ML Online Deployment API to provide this instructions to the Azure ML. Azure ML simply picks the model from the Azure ML model catalog and runs it through our NIM environment, which is provided as part of the NVIDIA AI Enterprise license, which you can request for. I'll tell you how to do that later. So within NIM, you can see there's a model optimization application that runs, which takes the Azure ML model and also some of the information specified in the deployment file and creates an optimized version of this model with all of the NVIDIA software intelligence baked in. And then it creates it spins up an inference server that can serve requests to ping this LLM model and then sends out their outputs from this optimized model. So NIM does both. It also does model optimization and making it performant across how many of GPUs you want to deploy on, and then it also serves this model for you. And you can see the model inference server interfaces with the Azure ML endpoint here. And since the server can support OpenAI spec, your users within your enterprise can simply send a prompt and in an OpenAI LLM request format, spec format, and then the endpoint would reply back in the OpenAI API spec response format. And you can simply use HTTP protocol. You can do streaming and non-streaming endpoints. All of that can be taken care by NIM. Here is an example of how the deployment file would look like as discussed in the previous slide. But before we go into this example, I want to show how the NVIDIA AI Enterprise would look at your end on Azure ML. So here is the preview of the NVIDIA AI Enterprise, where NVIDIA AI Enterprise has a bunch of different environments already provided to you for you to deploy models for different scenarios. Here you would also see an environment for like the NIM, the NVIDIA inference microservice environment will also be provided here. Along with it, you also can access some of the models that are proprietary models that are trained by NVIDIA, like Nemotron, NVGPT, and so on. Or you can also use the models from Azure ML model catalog and deploy it with one of the environments provided within the NVIDIA Enterprise Preview. So yeah. So before we go into the demo, I have created a workspace already for the purpose of this demo, and it's called the NIM Mixtral demo that I have here. In this demo, you can see that there are no endpoints that are currently present here. So I already have the files that are required for me to run the deployment. You can see I just need two files. Once I've created the workspace, I only need two files. One is the endpoint one, and then is a deployment one. Let's quickly look at the endpoint one. Endpoint one is very simple. There's the schema variable which shows like what schema to use, very specific to Azure ML. And then you have the endpoint name. In this case, just a custom name. And then you provide the authorization authentication mode to be the key, and that's it. Now let's go ahead and create an endpoint in our workspace of interest. So before you do that, you would have to log into your Azure and set your subscription and so on. I assume that you would have already done it. I have already done these steps. Now let's go ahead and create the endpoint in our demo. Okay, we were successfully able to deploy the endpoint, and let's go ahead and see if the endpoint is here. Let me refresh the page. Yes, I can see an endpoint here. So within the endpoint, we notice that there is no deployment here. Let's go ahead and deploy Mixtral 8x7B model, which is available in the model catalog of Azure ML. You can see it's within my workspace as well. So to deploy this model, I simply have to copy the model ID and provide it as part of my deployment file. So let me show you how my deployment file looks like. Here is my deployment file. Here is we have provided a bunch of different information like name of the deployment, the endpoint name, the model, the Azure ML model that we want to deploy, which we have just copied. I just pasted it here in advance, and then I use the environment. Here I use a test registry environment, but when you get access to NVAIE, you can use the environment, the NIM environment from there, and then you specify the instance type. In this case, I'm using the NC A100V4 instance, which has 4 A100 GPUs that are PCI based ones in a single instance. And then I provide some settings related to request so that we can serve requests at higher concurrency. And then we specify some variables which will get consumed by the NIM environment internally. These variables are the custom name that you want to give to your model, which you would later use to ping the model at the endpoint, and the number of GPUs that you want to deploy the service on. This can be less than or equal to the number of GPUs your instance has, and the maximum batch size, the input token length, and the output token length that you would expect your users to ping the LLM endpoint with. So that's it. With this information, which is good enough for NIM to go ahead and create a performant engine for your model. So let's go ahead and run this command. So the commands are available in this file. So let me copy paste that. That's it. All right. So the deployment has begun. This will take some time. We are done with our deployment. We can see that the deployment says it succeeded, and we can see our deployment being successful here. If you look at the logs of our deployment, then you can see that its application startup is complete and it started a server for us ready to consume. So let's go ahead and try out if this deployment works. For this, I'm going to be using Postman. In Postman, I'm going to provide the authorization key. Authorization key is available as part of this consume. So I just choose the key there, provide the key. I think, yeah. And then we have the headers, and this is some pre-populated one. Yeah, I already have the deployment name set. And then in the body, I send out an OpenAI based LLM request. Here is a model name. In the model name, it's equal to the model name I specified the deployment YAML file, and a list of messages with alternating roles between user and assistant and user. So the user asks like, who's your favorite CEO? Assistant replies, I'm a fan of Jensen. And user is like, hey, what does that company do? We expect the model to respond back with information on what does Nvidia do. We suggest a request for a particular set of tokens, and then we set whether streaming false or true. But first, let's do streaming false and see if that works. Yes, we can see we got a completion response. We get a response that says that Nvidia is a technology company, blah, 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 and all the way up to like autonomous vehicles and stuff. We can also run the same request with stream true. So let's check that out. So yeah, we can see that we have got a bunch of responses from the model. In each of this response, you can see there's like one token of content, like maybe if you see one of the ones in between, you can see there's like one token which says also. So yeah, the model can also support streaming output responses as well. So let's go ahead and see how this particular model would look like if deployed in a chatbot kind of scenario. Here is a code for the chatbot using the using Streamlit. We provide the same API URL as the endpoint. We provide the model name similar to our Postman request, and then we specify the deployment and then the API token. Here, let me use the API token we just copied, and that's it. There you go. Let's go ahead and run this application. Okay, application is now ready. So let's reload this. There you go. We have the chatbot up and ready. Let's go ahead and try again. There you go. So we have the response from our chat model. If I say, like, tell me about Nvidia, and this is the Mixtel model response about what Nvidia is. So if you are interested in like trying out Nvidia NIM for Azure, please use this link to apply for Nvidia NIM microservices for your enterprise. You can learn more about Nvidia AI Enterprise by clicking this link. You can also reach me on LinkedIn or email to know more about this solution. So let's go ahead and run it.
Now we will present how to deploy and use on an application a Vista 3D model as an Azure ML managed inference endpoint. My name is Manuel Reyes-Gomez. I will show you how to deploy the model. My colleague Michael will give an introduction to the model and to an application using the endpoint. As before, we're gonna be using resources contained on the Nvidia AI Enterprise registry. Quickly, we're gonna check that we're gonna use the Vista 3D model, and we are gonna, in order to deploy it, we're gonna use the NIM Vista 3D environment. As before, in order to deploy, we need to just run two simple commands. One to create the endpoint and one to do the deployment. The one for the endpoint is very simple. We just give the name and mode. For the deployment, basically, we just need to pass again the name of the deployment and of the endpoint, and what is the model that we want to use. As we could see, we are using the model on the Nvidia Enterprise registry, and we are using the right environment. After that, then we could once the commands are run, then we are going to be able to find the endpoints on the workspace that you use. Quickly, we could check the logs. On the logs, we could see that the model was deployed. We should be able to see the Vista 3D model is ready. And then, in order to consume it, you need to use the endpoint, the name of the deployment, and the authentication key. Next, Michael is going to show how to use these three resources to use the endpoint on an application.
Hi, everyone. My name is Michael Zephyr, and I'm going to talk to you a little bit about 𝗦𝗽𝗲𝗀. 𝗦𝗽𝗲 is an open source framework around medical imaging focused on things like transformations and architectures that are specific to the medical domain. And what you're seeing here today is our Nvidia 𝗦𝗽𝗲𝗀 Vista 3D NIM. A NIM is something that Manuel showed you earlier on how to set up and deploy on Azure ML. And I'm going to walk you through the Vista 3D model and what it's capable of doing. And so what we're going to see here is a little overview of Vista 3D. So Vista 3D is a foundational model around CT images. It has 126 classes within it, and it is optimized for few shot and zero shot learning, which means that it can learn on new tasks that it hasn't seen very much of, only with a few annotated sets of images. It can also work when you use interactive mode on things it hasn't seen before by using its point and click feature, which then uses an XYZ coordinate to sort of narrow in on a particular class. And what we're going to show you now is the usage of Vista 3D NIM in this demo interface here. And so we have three different samples that we can load, and we're going to use the abdomen CT example. And then we're going to need to fill in a few different things here for the inputs. The first one being the Azure ML endpoint. And so we're going to put that in here. And we want to make sure at the end of it that it says Vista 3D/infer, because that's the actual name of the endpoint within the NIM itself. Next, we're going to use the Azure deployment name. And here it's NIM Vista 3D deployment AML1. And last, we're going to put the authentication header in here, and that'll make sure that it authenticates correctly to the endpoint. And so what you're seeing here on the bottom is a nifty loaded. And what we're going to do is use one of these quick selects here. And so if we click on one of these and say we do organs, what that's going to do is select all the organs that are in that grouping in the label prompts section above. And it gives you a kind of quick way to organize and look through some prompts throughout the CT itself. So we'll click run. And if we give it a minute, you'll see it respond back with the segmentation. Now, the other thing we can do is look at a different set of anatomies here. And so one example of that could be kidney, kidney mass, and kidney tumor. And so we'll go through and we'll select those here really quickly. And then we'll go ahead and click run. And what you'll see here is on each of the views, I'll scroll through and you can see the kidney and the mass that's on the kidney itself on the different views. And what this does is really helps you speed up that annotation process. So again, not only does it have 126 classes included, but it also works well on fine-tuning and learning from minimal data to be able to tune to your specific task. And thanks again